Okay, so what we're doing today is dividing polynomials by a linear binomial. Okay, it's a very specific term to have something called a linear binomial. A binomial, you understand what that means. It's a polynomial that has two terms. But also, linear means that the highest power that the binomial can be, right, that the divisor can only be power of 1. So you can't use synthetic division on something that has like x squared in it or x to the third. Right? So the divisor, right, this one right here, this is called a linear binomial. Right? Because it's a polynomial that consists of two terms, but also the highest power is 1, right? X to the first power. Right? If we ever see an example where it has x to the second power, then we won't be able to use synthetic division. We will use long division, but we can't use synthetic. All right. So here's how we start with synthetic division. You begin with your divisor. You're going to find basically the root first. So whatever you see, if it's x minus 2, you would actually solve for that. And what you get is x equals 2. Okay, that's the number you're going to use in your synthetic division box. Okay, so it's almost like a division box for long division, except it's upside down. So your synthetic division box actually goes like this. Okay, and you're going to have a 2 on the outside, a positive 2. It's pretty much it's whatever it is, it's whatever the solution is when you set it equal to 0 and solve it. So if x is equal to 2, that's what I'm using over here on the outside of my synthetic division box. Okay, what goes inside the synthetic division box? Here, what you're going to use is only the coefficients and the constant. What do I mean by that? Well, you're going to plug in, or you're going to use only the 6, the negative 19, the positive 16, and the minus 4. You don't need to bring all of the x cubed, x squared, x with it. You only bring the coefficients with you, okay? Only the coefficients, all right? Okay, so now what do we do? So this is where it gets kind of fun. Synthetic division, you bring down the 6. That's your first step. So that first term, you always just bring it straight down to the bottom. So it's just 6 here. Next step, you're going to multiply this outer number with this value. 6, 2 times 6, that's going to give you 12. And where do you put that? You're going to put that right underneath the next coefficient, which is negative 19. Okay, so now what you have is a negative 19 and a positive 12. You're just going to combine those. Negative 19 plus 12. What do we get? That would be a negative 7. Now you're going to do it again. You're going to multiply 2. Sorry, when you multiply 2 times 6, you got 12, right? Now you're going to multiply 2 times 7. You're going to get negative 14. Okay, so negative 14 goes here. You have 16 minus 14. That's just 2, right? That's a positive 2. And now we do it one last time. 2 times 2 will give you positive 4. Okay? And if you combine those, negative 4 plus 4, you actually get 0, which is awesome because this last term represents your remainder. Okay? The last value that you get is the remainder. Okay, so you see we end up with 6, negative 7, and 2. Right? Those are my coefficients for my quotient. Okay, so what does that mean? I'm going to build my quotient out of these values. So I would have 6. Now, one of the rules would be, because I divided by x minus 2, this power up here, the power has to decrease by 3. From 3, it has to decrease by 1. So every power has to decrease by 1. So rather than having x to the third, it's actually going to be x squared. The next term is negative 7. Rather than having x squared, now I'm going to have just x. And then the last one is positive 2. And instead of having x power of 1, it's x power of 0. And that just means I don't have anything there. Okay, so it's just a constant. It's just 2. And take a look, I have a remainder of 0. So I don't need to add anything to the end. When I have a remainder of 0, I don't need to. So this ends up being my quotient. 6x squared minus 7x plus 2. All right. Any questions on the process of synthetic after that first example? I'm going a little fast. Okay. I'll try to go slower on the next one. All right. But do we have any questions? All right. So let's take a look at the next example. Example 2. Okay, I have a little star next to it. Why do you think that is? Take a look at the dividend and the divisor. Take a look at the divisor, all right? What is this divisor supposed to be? It's supposed to be a linear binomial. Is this a linear binomial? No. Tell me 2 reasons why it's not. Or give me other words to describe what you see there in that divisor. It's a trinomial, yeah, and it's a power of 2, which means it's not linear. It's a quadratic, right? This is a quadratic trinomial. So this one, we can divide, just not using synthetic, right? Synthetic only works with specific linear binomials. We can't use synthetic on this problem. We would have to do long division, okay? So cannot use synthetic to divide. We would need to use long division. Okay, so it's doable. We can use long division, but we're not going to do it right now, okay? This is just one to kind of test you. Like if I see something like this, right, it's not linear and it's not a binomial, I can't use the synthetic. I would have to try the long division method. Okay. Any questions on that? Cool. Okay. Next example. All right, let's go back. Now we're going to go back. We're going to continue to do more examples. All right. So you see we're being divided by x minus 4. Would you agree that this is a linear binomial now? Oh, you weren't done. Sorry. Yeah, linear binomial, right? X power of 1, and it's only 2 terms. So we can proceed to use synthetic. When I use synthetic, right, remember that I need to solve that binomial for 0. Okay, I need to find the root. In this case, that's going to be 4. That's what I use in the synthetic box, okay? So if I draw my box, 4 would be on the outside. And then I would just bring into the synthetic box the coefficients. So I have 6. Once again, the next coefficient would be -5. Okay, make sure that you include that negative. The next coefficient would be +2. And then the final one would be +1. All right. So what's nice about synthetic is like you don't have to worry about the variable. You only worry about the value of the number or the coefficients. Right? That's really all that you're working with. And then after that, you bring down your x values, or you bring down your x, but with one less in the power. So the power is all reduced by one. All right, so let's go ahead and try this. We know first step is always to bring down that leading term. The leading term is 6, so go ahead and just drop it every time. Every time you do a synthetic, you're just going to drop whatever value is there. All right, and then you do a little multiplication. Right, we have 4 times 6. That value is going to go right underneath -5, so that's positive 24. There you go, right? You're going to get 19, right? So positive 19, that's good. Okay. Then we multiply 4 times 19. Okay, 4 times 19. What does that give us? Yeah, 76. Good. All right. And then finally, we multiply 4. I'm sorry. Oops. Nope. Combine 2 and 76. 2 and 76, that's 78. And then we get 4 times 78. What's that going to be? Whoa, 312? Okay. All right, so that gets plugged in there. All right, so then the last thing we combine, right? 1 and 312, that's actually going to be 313. Remember that the last value represents the remainder. So this will be the remainder. So now I need to use, I need to write my coefficient, my quotient plus my remainder, okay? What's my quotient going to be? Well, my quotient would start with 6. If I did have x to the third, I have to drop one power, correct? So now it's x squared plus 19. If it was x squared, now it's x 78. If it was x, now it's no x, right? So this is my quotient, 6x squared plus 19x plus 78. But I also have a remainder plus a remainder of 313 all over. What was my original divisor? This is similar to the way we did it with long division. Yeah, the original divisor. Yeah, the whole thing, right? It's x minus 4. All right. So we kind of have to switch back to using the actual divisor, not just the 4. The 4 is a tool that we use in the synthetic division, but we'll need to use the x minus 4. So we have our quotient, which is here. This is sometimes denoted as q of x, q for quotient. And then this part here represents your remainder, so this is sometimes called r of x. So q for quotient, r for remainder. Okay, you might see that in Excel later. They might have something kind of like that, but you don't need to do anything with that functions or the function notation. You just have to make sure that you get the correct quotient and the correct remainder. All right, any questions there? So far, so good. All right. Okay, so now let's take a look at example 4. We got a little bit of a special case in example 4. Draw a little star there. All right. So first of all, check. Is that a linear binomial? Yeah, linear binomial. So we get to go ahead and move forward. We just have to find out what that root is. Well, the root is actually -4. So we're going to use -4 in our synthetic division box. Okay. The reason why example 4 has a star is because we're going to need some placeholders. What do you notice about the dividend? What kind of terms are missing? X squared term and also the x term, correct, right? So there's no x squared and there's no x, so we're going to need some placeholders. Everything else, all the examples we've done before, they were sequential. 3, 2, 1, right? This time it goes 4, 3, and then all the way to the constant. So we need to use some placeholders. All right. So before we begin, first let's try to fill some of this in. If it's x to the fourth, what would be the coefficient in front of x to the fourth? Yeah, it's a 1, right? So that means 1. Then we have -6, right? That's the coefficient for x to the third. So then since we don't have x squared, then we have a 0. Right? It's a 0. Remember that we would expand this and we would say x to the fourth minus 6x to the third plus 0x squared plus 0x and then plus 2, right? So we use zeros as placeholders. So I need 1 0 for x squared, another 0 for x, and then I can use 2 at the very end. Okay, questions on that before we begin this process? Do you mean on why we're adding space holders? Like why I added 0x squared? I rewrote the black one into what I have in green. Yeah, rewrote it into this. The reason for that is whenever we do division, all powers have to be showing. So if my first starts with x to the fourth, then I need to see everything after that. I need to see x to the third, I need to see x squared, I need to see x to the first, and then I need to see the final constant. But if I don't have it in the original, I need to use 0 as a space holder. Okay, why does this count? Why does this work? Because 0 times anything is still 0, but in the meantime, it's creating the space for me here and here. Okay, the reason for that has a lot to do with what we did the other day with long division, is that without those space holders, sometimes you'll end up lining up terms that are not like, so you can't add or subtract them. So by using the space holders, it guarantees that you will be able to line up your like terms correctly. Okay? So anytime the polynomial has gaps, right? Anytime there's a gap, right? There's a power that's missing that should be there, right? If you're going in descending order, 4, 3, I should have something with a 2, x power 2, and then I should have something with x power 1. And if I don't have them, I need to write it in myself, but I use a 0, okay? Because 0 is still, basically it's like I added nothing, okay? But in the meantime, it serves as a space holder. Okay. So it builds on this idea that we talked about last time when we were doing long division. Okay. Just know that you'll need to have space holders if your polynomial does not go in order from 4 to 3 to 2 to 1 to none. Okay. So let's try this one out. All right, let's see how it goes. So now that I do have those space holders, and I've used my zeros in the synthetic as well, first we bring down the 1, right? Always first step, bring that down. -4 times a 1, it's -4. Okay, so -6 minus 4, that's -10. And then -4 times -10 would be +40. So now I have 0 plus 40, that's 40. -4 times 40, that would be -160. So 0 minus 160 is -160. -4 times -160 could be positive. No, that's a mistake. Sorry, that's 640, not 720. So my remainder, 642. Okay, so now we create our quotient. Our quotient will have 1. Instead of x to the fourth, we drop a power. So it actually becomes x to the third minus 10. Instead of x to the third, we drop a power, so it's actually x squared plus 40. Instead of x squared, it's x, right? That's why I need those space holders, right? I need those space holders. And then minus 160. Okay, so this would represent my quotient, or sometimes called q of x, and then plus my remainder, 642 all over x plus 4, right? Remember to use the original divisor for your remainder. And that's sometimes called r of x. All right, any questions there? All right, let's move on. Let me go ahead and have you write down these last two examples. I'm gonna take a quick little water break. Okay, so with number 5, once again, we're checking to see, do I have a linear binomial down here? Is my divisor a linear binomial? Would you agree that it's a linear binomial? Okay, we have a little bit of uncertainty, right? So how many terms? There's only 2, right? There's 2x and then minus 1. So it is a binomial. Is it linear? You're checking for the power. Doesn't matter what the coefficient is, but what is the power that x has? Is that a power of 1? Then it is a linear, right? It's a linear, even though it has a coefficient of 2, right? Imagine it's like a line, y equals 2x minus 1. Okay, that's still linear. Okay, so we can move forward. Now, remember, you're solving for the root, which means you set the denominator equal to 0, and you solve it. Because this is going to tell you what your value will be, what you're going to use in the synthetic box. So it's not going to be just minus 1. You're not going to just flip that, make it positive. You're going to solve for x. So first you add 1. You have 2x is equal to 1, and you divide by 2. So x equals 1/2. Okay, x equals 1/2. So that's actually going to be our root, right? That's what we're going to be trying to divide or use in our synthetic box, 1/2. All right, so if I were to set this up, we're going to work with a fraction, 1/2. Okay, now, I want you to notice the dividend. Do we have gaps? We need some space holders, right? Because it goes x to the third all the way to constant. That means I have 2 space holders missing. I don't have anything with x squared. I don't have anything with x either. So I need to create those. So we can rewrite this as 8x to the third plus 0x squared plus 0x and then minus 1. Very similar to the one from before. All right. So let's go ahead and use those coefficients. 8, 0, 0, and minus 1. All right. So first step we know is to drop 8. So 8 times 1/2, well, 1/2 times 8 is 4. All right, so we get 4. 0 plus 4 is just 4. Okay, and then we're going to have 1/2 times 4. 1/2 times 4 is 2. So 0 and 2, that's just 2. Oops. And then 1/2 times 2, that's a positive 1. So this last term, which is my remainder, negative 1 plus 1 ends up being 0. So that's awesome, right? That's our remainder. So we have a remainder of 0, aka no remainder. All right. So now, this then becomes my new quotient, right? 8 instead of x to the third, that's because that's what the original power was, we drop a power, so that's 8x squared. Then that'll be 4x, and then plus 2. Okay. Now, the only thing that is tricky about synthetic is that sometimes you do get a quotient that needs to be factored out, okay? For the same reason that typically, whenever there is a coefficient in front of x in your divisor, there's going to be a GCF here that needs to be removed out of your quotient, okay? Needs to be removed out of this quotient. What is that GCF that you see between 8, 4, and 2? Yeah, there's a GCF of 2, okay? So you have to factor out that 2. You're left with 4x squared plus 2x plus 1, all right? So the quotient is this right here, okay? 4x squared plus 2x plus 1. This would be my quotient, all right? And you can see why that's kind of the case. Because remember, the quotient times the divisor should equal the dividend, right? Meaning, if I take my divisor and I multiply it times my quotient, it should equal my dividend, okay? And it wouldn't make a whole lot of sense, right? Here you can see, yeah, this would work, right? 2x times 4x squared, yeah, that gives me the 8x cubed, right? I could see that how that works. But if we had not removed the GCF, and you would have left it as 8, and this one has 4, and this one has 2, you can already tell with that first distribution, hey, that's actually 16, and that's not going to give us 8, right? So that means that something's kind of off. This typically happens with synthetic. Whenever the divisor has a coefficient, 2 or 3 or 4, whatever, at the end, once you actually have found the quotient, at this point, there's going to be a GCF that you have to remove. Remove the GCF because then the actual quotient is whatever will be left inside. Okay. So this one is a tricky one. X minus 1/2. Yeah, linear binomial, right? The 1/2, that's okay. But we have 2 terms and it's a power 1. So we're going to use that to help us solve for the root. X minus 1/2 is equal to 0. So x will equal 1/2. All right. So let's go ahead and plug it in to our synthetic box. That's 1/2. All right. And let's take a look. Let's see. I have x to the third, x squared, x, and then my constant. So they're already all in order, right? They're already in order. So I just need to then just highlight my coefficients. If there is no coefficient in front of x, that means that it's a positive 1. And then I also have my constant, positive 1. So we get 3, negative 2, positive 1, and positive 1 again. So let's go ahead and try to move through this using some fractions. I know it's scary stuff. 3 comes down. I have 3 times half. 3 times half is 3 halves. Okay. So now we have to combine negative 2 plus 3 halves. Well, 3 halves is the same thing as 1.5. Okay. So this ends up being negative 1/2. Now we have 1/2 times negative 1/2. That's negative 1/4. So 1 minus 1/4, that's 3/4. And 1/2 times 3/4, that's 3/8. Okay. So we had to do a little converting. 1, that's the same thing as 8/8, by the way. So 8/8 plus 3/8, that's just 11/8. So what we get here would be 3x squared minus 1/2 x plus 3/4 plus my remainder, 11 over 8 all over x minus 1/2. All right, so this part looks kind of funky, right? You have like a fraction over a fraction. Okay, shortcut when this kind of stuff happens. 11 over 8 all over x minus 1/2. Okay, this denominator drops. So really what you get is 11 all over 8 times x minus 1/2. All right, and that would be the cleaned up version of your remainder, but the rest stays the same. Okay, so that's what we got. Here's my quotient, and here's my remainder. Okay, and that's it for today.